Well, lesson 12 then, as you can see, is titled Exception Handling. And so this deals with the fact that we can have errors in our program, and we would not, or at least our users would not really appreciate it if those errors would cause the program to crash while they're using it. So we need to take a look at how we handle those issues. Our objectives for this lesson are to have you understand what syntax errors are, define what logic errors are, and define what exception errors are. So those are the three error types, categories, essentially, that we'll encounter as a programmer. And so we want to make sure we understand what each is and how to deal with them. Also, we'll be creating a program which implements exception handling with a try-catch block. So you'll see that the way that that works is we'll attempt to perform a statement, and if that statement fails, then we'll attempt to catch it. And then also you'll learn about try-catch finally blocks, which you'll see that there are times when we catch the error, but we still need to do some additional steps, some additional statements that need to run, like closing up open database files and things of that nature. So usually we stick those in the finally block, which comes after the catch. And we'll show you all that here in just a bit. Also, we'll be talking about APIs. We've got a little video for you to show you what an application programming interface is and kind of how you would use it as a programmer. And we'll also talk again about libraries and frameworks. We've covered a lot of this so far as we've gone through the course, just kind of summarizing the whole concept of how we get additional code that we can use within our programming. And then also locating the documentation. So I've arranged some links and whatnot for you so that you can get to the documentation for a particular language, particular framework pretty quickly. So let's go ahead and start here with understanding exception handling. As it says, there's at least 3 distinguishable types of errors in computer programming. So syntax errors, also known as parsing errors, are the most common. You will encounter them while you're learning your new programming language. So as you've been writing your programs, you get those little red squigglies that pop up in your Visual Studio. Those are representing syntax errors. And so usually those can be caught, at least if we're using a good source code editor, those could be caught during the actual creation of your code. But if not, we'll certainly see those when we go and try to compile it and run it. In fact, most syntax errors, again, within Visual Studio or any type of an advanced IDE, pretty much you just wouldn't be able to compile the program. So that it would never ever get to the user if it had syntax errors in it. Logic errors would be things like when we create an algorithm that maybe returns a divide by 0 error. And many times that's not really a programming issue. It's that we haven't allowed for the fact that we're taking user input, and the user may put in invalid input, and that may actually cause that divide by 0 error. So we can handle that, and you'll see that will be demonstrated here in a little bit. And then also we have what are called exceptions. So even if we don't have any expressions that are syntactically and logically in error, the program may still cause errors when it executes due to exceptions, as they call it, occurring. So good example, when we access a resource on the network or attempt to access a file, like we've been doing with the file IO there in the previous lesson, if that resource isn't available, then that's going to cause an exception, because the program's going to attempt to go and access that resource. It's not available, and that will crash your program at that point. It will become unusable. So what we'd like to do is we'd like to be able to handle those exceptions, and even though the error may occur, the exception may occur, the program itself will not crash. It'll continue to run. It'll just recycle back to the last point where it was left in the program before the crash occurred. So in the .NET framework, we have standard exception handling, and it pretty much will handle any of our runtime errors. So runtime errors would be errors that are occurring while the program is running. So in this section, as I mentioned to you earlier, we're going to take a look at the different blocks that we use to handle all of this, the try, the catch, and the finally. Continuing on from there, an exception is an error condition that occurs during the execution of the program, so during runtime. When this happens, the runtime creates an object that represents the error. So this is built into the framework itself. So as the common language runtime, which is what processes your executable code on the client system, as that's running the code, when it encounters one of these exceptions, then it's going to do what they call throwing an error. So unless we catch the error that's being thrown, the program is just going to crash on us or terminate, as it says there. So again, we get back to some of the examples here. One of the most common ones is that divide by zero exception. So that's why we talk about it here quite a bit. So what you'll see is that in the .NET framework, an exception is represented then by the use of this object that's being created when the exception occurs. So what we'll do is we'll capture that object because it'll have all the information about the error that's in there. And then we can use that information actually even to display back to the user what the message is for that particular error. So in order to handle our exceptions, we've got try-catch blocks, and then we'll show you a little bit later on the try-catch finally blocks. So the idea is that in the try area of the program, that's where we'll attempt to do attempt to run a statement that may possibly generate an exception, like attempting to open a file that may not actually exist on the system. So we've got an example here then to demonstrate how we would handle that type of an error. And so you can see that we are using the system and also the system IO libraries here because we are going to be using the stream reader in this case to demonstrate the try-catch block. The way that this code is set up is in the main, we're just simply calling a custom method. And then in the custom method, you can see what we're doing is just assigning a new stream reader and making it null initially. And then down here, we're trying to open up this text file. If that text file doesn't exist, then in the catch block, we will want to catch the exception type. And this is actually the most difficult part of using try-catch blocks is you have to know what the different object types are that would occur. So in this particular case, it's a file not found exception. So that's the actual object type that's being created when the exception occurs. And so in the catch block, what we're doing here in the parentheses is actually creating the variable that we can use down in here internally. So what we're telling the compiler at this point is you need to create for us a new variable of type file not found exception. So that's the actual object type. And for the purposes of this catch block, we want to refer to it by this name here, FNFE. So we shortened what the actual object name is, right? So now you can see that we can actually use the message property then of that object that we just created an instance of and write it out to the screen. And then that will display the file not found exception message to the user. But then the program will just come back to the main again. It won't actually crash at that point. In the other catch block here, this is a more generic catch. So, you know, as you're learning how to do the try catches and what the different exception types are going to be, you could just use this generic exception and that will report, as you can see down here, we're just creating and assigning a name of EX to it as the variable name, and then down here actually using the message property to display its output. So this would catch all exceptions and just kind of give you a generic message, an exception occurred. It wouldn't tell you specifically that it was a file not found exception. And this is important, the order here of these catch blocks, because notice we can use more than one catch block because we might have several possibilities, several error types that we're expecting could occur in this particular sequence. It's important that we put the more specific exceptions first in the list and the more general exceptions last in the list, because what happens is it's kind of like an if statement almost. It's as the common language runtime is going through and reading the code, it's reading it line by line, and then it'll process the first catch, and if that is the actual error, it'll go ahead and generate this output, and it'll skip the next catch or all the rest of the catches. So the idea is that we want to have the more specific errors here first. If those specific errors aren't what is actually encountered when the program is run, then we'll have a generic one at the end, kind of a catch-all, so to speak, right? That'll still not, keep the program from crashing and generate some sort of a generic message to let them know that an error has occurred. So more specific first, least specific, more general should come at the end. So essentially, the point is that you have the curly braces for each one of those sections, right? We have the try section, and then it has its curly braces and what we want to do and the steps that we want to attempt to run. And then if an error occurs, then the most appropriate catch block in order listed will be basically thrown to the screen or display the message out to the screen there. And then again, outside of that custom method, when the error, after the error has been identified, it'll just go back to the main method again. So if we had additional code running after that exception test, that code would still continue to run. So in this example here, I'm just having you basically copy this code. So let's go ahead and create a new project here. This will be a C# console. We'll just call this error handling. Actually, what I should do is make that my solution name, and then let's just call this first one try catch. Okay, so my first project's gonna be try catch, and then this is gonna be in a solution called error handling. So then we'll go ahead and just copy the code that we have here. Go ahead and paste it in. So we've got our two using directives here, system.io. Namespace is just what I copied in there from the example code. And so then in our program here, we're calling the exception test. Here's our custom method. And then here's the stream reader being created and the attempt then to read the contents of this file. So let me double check and see if I still have that file on my root. Yeah, so I do still have a file there. This is text is what I wrote in there. So that's on my C drive. So this should not throw an error. So let's go ahead and run it with a Control F5. And you can see that it opened the text file, no problem, displayed its contents. Now what I'll do is I'll go back and I'll just rename that file so it won't be able to find it. Okay, so I just renamed it to data old. So that doesn't match this file name here now. So we'll go ahead and run this again. Control F5. And now you can see there the error occurred, but the program did not crash because we handled it. So we were able to get this text message right here because the file not found exception generated this, using the console write line here, generated that text message that reads could not find the file and then the specific file name. But the main thing is that the program didn't crash. In fact, what I did want to demonstrate too is that if we don't do any of the catches here, then we should get a failure. Yeah, so there it won't even build. You can see right there, this is more like a syntax here if you think about it, because we've got a try block, but we have to have a matching, at least one matching catch block would be a syntactic rule essentially. So in that case, the program crashed. In fact, that's the other thing I wanted to do here. just to show you that we could run a console.write line and put in here, my program is still running. Just to show that we do get to the line that comes after the call to the custom method there. So let's go ahead and run that. So there we get the custom error, and then again, it is running the next statement. It goes back to the main. You can see it runs the next statement. If we remove those catches again, just comment them out. It's Control K plus C, by the way, to do a quick comment. You know what, though? This is not still going to do what I exactly wanted to do, because it's just going to have a build error. Yeah, so that, because it's a syntactic error, it won't build at all. So let me think. A better demonstration would be just to run it without the try catch. So let's do this. So here we're just going to run it up in the main, not call the whole try catch block at all. Let's see if we can run that. Yeah, that's what I thought. It's going to give me a build error because I also need to put this in as a string first. String SR, file open. Oh, that's right. It's not a string. It's a stream reader SR. All right. Now let's go ahead and run it, and it's not going to call the exception, but it still might not build here, so I better just comment this out. There we go, finally. Okay, so here, this would be the result if we don't do the error handling. So it just generates the error. You know, it says unhandled exception. In this case, it was from the system IO library, file not exception. But and it looks like it's specific. You know, it's very similar to the actual catch message that we saw. But what you'll see here now is that we didn't get the next line of code, this this statement here, to run, because the program has crashed at this point. So that's the difference then between catching it and not catching it, I guess would be the simplest way to say that. So let's go back.
That's a huge difference, and it makes sense too.
That's good. That's the point I am trying to make, is that if we break the program, that's a very bad user experience. They have to go back and, you know, reload the program again. Whereas we run these try catches, we can catch the errors, but still have the program running so that the user can continue. Let's go take a look at a couple more of these examples here. So in the last example, it just says that we were talking about the file IO errors, but that exceptions can be used to avoid many possible situations when you're writing your code. And then this is the example, or the kind of the concept I was trying to convey earlier, that you might not have any control over the fact that there's going to be an error in your program. It may be that the user, if you're taking input from the user doesn't input their value correctly. You know, you ask them to type in a numeric value and they type in hello world, right? So that certainly couldn't be translated or converted. Even if you had the conversion code in your program, that could not be converted into a numeric value. So more than likely then what's going to happen is you're going to end up with if you're doing a mathematical problem, then within the program that takes the user's input and divides it into some number, that's going to cause an exception. And these are referred to as arithmetic exceptions. And so in this example, we're going to set up that divide by zero error. We're just going to hard code the values in. So we've got integer x and integer y, and you can see y is the zero value. And so then here we've got this custom method that we're creating called divide. It takes in 2 ints and then attempts to divide x by y, which would be a divide by zero error. And so we should then encounter the arithmetic exception, which would then output this text string here. as opposed to, again, the generic exception that would occur down here. So if it's other than a arithmetic exception, then it should jump down here to this catch block. So let's go ahead and put this one in to our Visual Studio. So I'm just going to create a new project here. C# console. Call this divide by 0 error. And paste our copied code in there. So in this example, we're only using the system directive. We don't need the system IO because we're not attempting to open or write to any files. So just recovering what we got here, we got two ints, x and y. We're going to pass them into this custom method divide, which attempts to then divide x by y. Y is a 0 value, so that's an error. And so then we should get this specific text output. In fact, this is what I should have done on the other one there. That's right. See, this one here, you can see actually has some string text inserted in there to make it clear to us which of the exceptions is actually being used. Okay, so let's go ahead and run it. We already got hard-coded values here, so it'll just throw the error immediately. So arithmetic exception handler, so that's the text string you see right here, and then the 0, that's our event or our exception that's being passed in to the catch here, and we're using that as the output then that it's going to display the message. In this example here, I didn't use the string interpolation method. I used the old composite format where we had the placeholders for the variable. But if we just take that variable away from there and stick it in here, and then we just need to put the string interpolation operator there. So just kind of updating the output, that's all I'm doing there. So up until this point, we've just been taking a look at a couple of different examples. We had the file not found exception, and then we had the divide by 0 exception. But we haven't introduced you, well, we introduced you earlier, but we haven't shown you then how to actually incorporate the finally block. So the whole idea of the finally block is that whatever code is in there will always be executed regardless of whether an exception is thrown or not. And then in the note here, I mentioned, because this is something I happened to stumble across here last week, I think it was, that in the Microsoft documentation now, that they are actually recommending that when we're doing our file IO, that using that keyword using is the preferred method as opposed to using a finally block to close up an open object. So if you think about it, when you're doing file IO, you're attempting to open up a file, and if that file is open, but then the error occurs after that, maybe a divide by 0 error or something to that effect, that file would not get closed if the program crashes. So that file remains open in memory, and so now what's happening is we've got what's called a memory leak, essentially. So that's the using statement, and this is strictly for file IO now. The using statement does the same thing as a finally, as long as you open your file with the using statement, it will always close itself even when an error occurs. So that's part of the code that's written into the using statement. So if we're not opening files, then we would use the finally block. But if we're dealing with files and we've got the keyword using when we open that file, we really don't have to worry about closing that file.
So if you're writing a class to save, would you want it to implement the iDisposable interface, or is that not too important?
Well, that's using is mainly for the iDisposable interfaces. In fact, if you go, I guess I didn't put the link in there. I should have done that. That particular document that I was looking at basically says that if you are using a using, that is going to interface with any iDisposables. The finally would be used in the case where you don't have an iDisposable object.
Right, but if you write a class, like your own class that just has a whole bunch of variables in it and lists, and you want to serialize it to store it, you still have to implement the iDisposable interface within that class, correct? To be able to use it?
You should. So if you do, then you could have the using statement with that particular class. You wouldn't need the finally. But if you create a class that doesn't incorporate the iDisposable interface, then you would want to use the finally.
Okay, thank you.
You're welcome. And this just kind of continues on that your program could end up in a dirty or an unstable state, they call it. And so again, the finally block is used there to kind of clean up the code that we had previously executed in the program, just to make sure that everything's in good shape when the program ends. So our next example then, you can see is we are going to create this custom method here, which is the try catch finally test. And so we're using the stream reader again. We're attempting to open up a file and then write the contents of that file to the screen. But if that file doesn't exist, then we'll get the file not exception. That would be the one that would fire off. It would not be this one. But then at the very end, you can see now we're actually closing that stream reader object. So notice we're not using the using statement in this example. If we had done what would be right about here, using SR equals file open text data text, then I would not need to have this code down here, because that using statement does the same thing as a finally. Whenever there's an exception, it automatically closes the resource that was part of the using statement. So this one here doesn't use that. This one here uses the finally block. So I'll copy that. Let's go back and make one new program in this one here. C# console. Let's make this try catch finally. And paste our code in there.
Don't forget to set it.
Yeah, thank you. There it is, startup project for our try catch finally there. Let me double check. I think I still have the file renamed. So this should throw the error. The file is renamed there. It's data old instead of just data.txt. So I'll run it, Control F5. So you don't really see the results of the finally, but here's the error again. We've got the file cannot be found, and it identifies the actual file. And then the program doesn't crash, it just ends because that's, you know, it read all the statements and it was done running at that point in time, but it did not crash, it handled the exception. The thing of it is, what we can't see is that in the background there, that finally block was run, and so the SR file is actually closed up. Okay, further down now, we're taking a look at actually creating custom methods and then calling the custom methods within our try block. So if you think about it, this is just a more efficient way of, when we got multiple methods that we want to run, it's a lot easier just to kind of sequence them inside of a try block and then have the catches for what the possible errors might be, as opposed to within the custom method down here, which is write file and read file. You know, we could have put the same try catch inside of here, but then we're kind of being redundant, right? We're not adhering to the dry principle, don't repeat ourselves. So as much as possible, we want to avoid that. So instead, what we do is we create the custom blocks of code that we want to have run, and we call them from within the try block. So we're back to using System IO again too, because we're using the stream reader and the stream writer. Go ahead and copy this and back to our error handling, another new project. C#. And this one here, how about handling exceptions in custom methods? A little bit more precise. Okay, so that's this one here. We'll make it the startup and then replace the code. Okay, so again, the directives are system IO. Just inside the main is where we set up the try and the 2 catch blocks. We're not using a finally here, really not necessary, because we've got the using being used down here when we open up, or in both cases, we're opening the file, right? If we're reading from the file, we have to open it to take the contents of the file. And if we're writing to the file, we also have to open the file to be able to write the contents to the file. So since we're using the using statements in this example, we don't need to have a finally up here. So this is going to write out now into actually my repos source folder. In fact, I don't think did I show you that on Tuesday, how to get to your repos folder? Does that sound familiar? Anybody?
I don't think so.
Okay, well, this will be a good time to do that then. The way that Visual Studio works is that we don't give it a path where to save this file. It's going to put that file into the same folder where our program is running from. And so when you're doing the Control F5, either the start debugging or the start without debugging when you're running your code here, what it's actually doing is it's compiling that code into a subfolder of where your project is, called the bin folder. And it'll be inside of the bin folder, and now they've actually added a new subfolder, which I think is called System32. And inside of there is where the file that this program creates will actually be found. So let's go ahead and run the code. So it's just like we've seen before, the basic, take the text in, read the content from the console that the user's typing in, write it out to a text file. And then down here, we're going to just read the contents of that text file. So that should all run without error. Let's go ahead and run it. So this is some text to be saved. And see, here's that full path. As soon as I press enter, it's telling me where, and then also it looks redundant here, but what we've done is we've taken in the input from the user, and then we read the file and we displayed the contents of that file back out again. So that's why we see the text I typed in there twice. But then underneath, after I pressed enter, notice that it is showing me the path that we're talking about. So this is my user folder. Then it'll be source, repos, and then the project name, which is error handling. And then inside of there, I should say that's the solution name, error handling. Then the project name, handling exceptions and custom methods. And there's that bin folder. And that's right, there's a debug folder. And then this is the one I couldn't remember. It's a Netcore app 3, 3.1 actually. And then / handling exception custom methods. There's the actual executable that's running. So what that means is, let's open up a file manager here. Or File Explorer, I guess they call it now in Windows. And so what we need to do is navigate, navigate to our C drive here, find the users folder, and then your name inside of users. And then from there, scroll down and look for the source folder. Inside of source, you've got repos. Now here's all the different solutions that we created. So the one we're looking at today is just error handling, this one right here. And then this is the one we're working on right now, the handling exceptions custom methods. Then we go into the bin folder, debug, and then Netcore app 3.1, And there is the actual code that's being generated then each time that you run that debug. So here's the actual executable. In fact, if I double click on this, it'll run the program. And then here is the output that we just generated from that program. So you open that up, and there's the text that I typed in. Just to show you, let's go ahead and close the program and just show you can actually just run it from here now. So this is if you want to share your program with friends and neighbors, you just grab the executable and copy it to them, and then they can double click, run it. It'll open up in a console and it'll function just as you expect it to. Okay, so this time it reads, this is the text I created. That's right, I gotta use the cursor. I'm on a console, aren't I? There we go. So this is the text that I created from running the exe file in repos. Press enter. Now let's look at our text file, and there's the new text. So you see it's the same program, right? It's just that this is the actual compiled version of our code that we can now run on any Windows operating system. To finish up this lecture here, I'm just going to kind of take a look at some of the other options that are available to you as far as incorporating pre-written code into your programs. And so one of the common things that you'll use will be APIs. In fact, a lot of times you're using APIs and don't even know it. So we got a good video here that kind of gives you an example of how an API works. So we'll take a look at that, and then we'll come on back.
Connectivity is an amazing thing. By now, we're all used to the instant connectivity that puts the world at our fingertips. From desktops or devices, we can purchase, post, pin, and pick anything, anywhere. We are connected to the world and each other like never before. But how does it happen? How does data get from here to there? How do different devices and applications connect with each other to allow us to place an order, make a reservation, or book a flight with just a few taps or clicks? The unsung hero of our connected world is the Application Programming Interface, or API. It's the engine under the hood and is behind the scenes that we take for granted, but it's what makes possible all the interactivity we've come to expect and rely upon. But exactly what is an API? It's a question everyone asks. Okay, not really, but we're glad you did. The textbook definition goes something like this. In computer programming, an application programming interface, API, is a set of routines, protocols, and tools for building software applications. An API expresses a software component in terms of its operations, inputs, outputs, and underlying types. Okay, to speak plainly, an API is the messenger that takes requests and tells a system what you want to do, and then returns the response back to you. To give you a familiar example, think of an API as a waiter in a restaurant. Imagine you're sitting at the table with a menu of choices to order from, and the kitchen is the part of the system which will prepare your order. What's missing is the critical link to communicate your order to the kitchen and deliver your food back to your table. That's where the waiter, or API, comes in. The waiter is the messenger that takes your request or order and tells the system, in this case the kitchen, what to do, and then delivers the response back to you, in this case, food. Now that we've whetted your appetite, let's apply this to a real API example. You're probably familiar with the process of searching for airline flights online. Just like at a restaurant, you have a menu of options to choose from. A drop-down menu in this case. You choose a departure city and date, a return city and date, cabin class, and other variables. In order to book your flight, you interact with the airline's website to access the airline's database to see if any seats are available on those dates and what the cost might be based on certain variables. But what if you're not using the airline's website, which has direct access to the information? What if you are using an online travel service that aggregates information from many different airlines? The travel service interacts with the airline's API. The API is the interface that, like your helpful waiter, can be asked by that online travel service to get information from the airline system over the internet to book seats, choose meal preferences, or baggage options. It also then takes the airline's response to your request and delivers it right back to the online travel service, which then shows it to you. So now you can see that it's APIs that make it possible for us all to use travel sites. The same goes for all interactions between applications, data, and devices. They all have APIs that allow computers to operate them, and that's what ultimately creates connectivity. So whenever you think of an API, just think of it as your waiter running back and forth between applications, databases, and devices to deliver data and create the connectivity that puts the world at our fingertips. And whenever you think of creating an API, think MuleSoft.
That's actually an easier way to perspect on what an API is.
I'm sorry, what's the question about the API?
It wasn't a question. I was trying to say that gives us an easier way of understanding what an API is.
Yeah,
the way and
exactly.
all that.
Yeah, there's a lot of APIs out there too. So as a programmer, well, if you think about some of these large websites that are out there, like Trivago and whatnot, that actually are tapping into hotel databases and airline databases and other leisure activity databases, the whole reason they can operate is because the companies that store all that data on their databases have actually created this interface, which is the API, that this third-party company can utilize to actually gain access to their database. Now, you're going to have an account, obviously, with these companies. They don't just let anybody come in willy-nilly and use their APIs, because that would invite malicious activity. So usually you'll set up an account on whichever service it is that you're attempting to use, or services. And once you're verified as being an official business, then you'll be able to have certain levels of access to their database. Even write access, if you think about it, like in the case of an airline or hotel, because they do have to record the reservations. But they have a lot of protections in place to make sure that there aren't any malicious programs out there that are, attempting to put bad data into their system. But that's just the most common example you can think of these days is those travel services, because airlines, hotels, what they used a good term, in fact, in that video there, they aggregate all that information. So you don't have to go to, say, just American Airlines site and you can only see American Airlines flights. In an aggregated site, you're getting information from all the airlines so that you could actually compare pricing, with one airline to another within a single interface. So I've just given some examples then below here of some of the APIs that you might encounter. Most of them are coming, a lot of them, from a programmer standpoint outside of travel and hotel and whatnot. A lot of the hardcore code that we use, well, actually Amazon's a good example. Like you're familiar with the concept of an Alexa, which you can actually talk to the device and it'll take your voice, convert it into a digital command, and that digital command then gets processed on the server, and then whatever the results of that is converted back into sound so that we can actually hear it coming back out from that device. And I looked into that at one time, and this was a few years ago, and at that time Amazon was charging, I believe it would charge the client 50 cents per word that was being translated. So it seemed like that was kind of an expensive service if you were, going to use it as a third party.
Wow, is that true? Because we actually have that.
You have a program that's interacting with the Alexa
No, we
device,
actually have Alexa.
API. Well, yeah, but that's a device that came from Amazon, right?
Yeah.
Okay, so that Amazon device then is utilizing that Amazon API, and there's actually two of them. I forget, one of them's called Lex. So one is the voice to digital conversion, and then the other one, I guess, is just back from that, if I recall it. It's, like I said, been a few years since I did the research on this, but they are using their own service essentially when you have an Alexa device. But if you think about, like in my automobile now, I can, and this is kind of not the best example when I think about it either, but I use like Android Auto in my car, but it's all going through the entertainment system within the car. So the car itself, the entertainment system software that's in that car is utilizing that Amazon Assistant API that's provided to it. So that's how I can interact with that Amazon API, is that API is being made available to me through the car's software, the entertainment system that's built into the car. This is just an example. This is like over a decade ago. When I first started examining Facebook, it was back about 2007, as I recall it. And I was looking at it, mainly from a research standpoint, trying to identify what the components were that make it attractive to users, and what kind of functionality it's actually providing. And this is when I discovered that they had this developers interface. So you can see that you can actually go to developers.facebook.com and you could create an account there and start actually putting your own applications into Facebook. The idea that I had at the time was this thing called Fun Zone. I was going to create some games, and then users through Facebook could come to the Fun Zone and play those games. But that was just a wild idea that really never got fleshed out. I got as far as creating the account and kind of setting it up here, but it never actually got down to the point where we were creating any products. As far as Google developers goes, you can use Google Wallet in stores now to make payments. So those payment devices are using the Google Payment API to actually interact with your Google payment account. Same thing with logins. You might be in an organization like MSJC. We have access to Google through MSJC. In fact, if you look at my web browser right now, you'll see I'm logged in with my MSJC account here. So every time that I get authenticated, it's the credential management API that's being used. Both Microsoft, Google, and apparently Facebook too are kind of trying to capture this market of credential management, where their goal is to have everybody else's programs use their software, trying to simplify it for the user so that we can kind of get to this point where we only have a single login, and we can get access to all the different resources instead of having to have a different name and password for every freaking website that you need to have access to. So the idea would be that you would use your Microsoft account or your Google account, and then that other software developer would basically be given a return token. So when you log into their website, when you say I want to use my Google account or I want to use my Microsoft account, then those APIs return a token back to that software that says that the information you typed in, username and password, that was valid and you have been authenticated. So you are the user you claim to be, and so now you have whatever level of access you should have in that particular website or program. So that's pretty popular out there as far as APIs these days too. And I'm sure there's a lot of them being worked on that I'm not even familiar with, that will be these phenomenal new pieces of software that everybody must have in a few years. But who knows what they are? Maybe it'll be something that you write. So API is a pretty powerful concept. Just you've got programs that are running on these servers, and especially in these really large organizations like Google and Microsoft, Facebook, Twitter, they have servers all over the world, so you get good responsive times from them as well, instead of having one server dedicated, for all your login activities or whatever type of activities are going on. So another way to get access to collections of pre-written code would be to use libraries. And so the example that I give you here is the JavaScript libraries, jQuery and React. And a library, and if you think of the terms of, we've been working in the Microsoft .NET framework, most of our coding examples, the system and the system I/O, those are actual libraries. Now those libraries happen to be combined with the Microsoft .NET framework. So a framework, part of what a framework includes would be libraries of reusable code that other people have written that we can then use in our code. So in the case of the JavaScript libraries, like this jQuery is a very popular library in the JavaScript world because it does a couple of things for you. It gives you some really nice graphical interfaces to use, like date controls and calendar, well, that is a calendar control, number sliders. And the other aspect, in addition to giving these cool interfaces, is that it also, if you use the jQuery code, it's going to make your web page that uses the jQuery code more compatible with all of the web browsers out there. So it's not as much of an issue as it used to be, the cross-browser platform compatibility. For the most part now, most of the code that we write runs in all web browsers, but will still be exceptions. There will always be exceptions, and so the jQuery helps out with those exceptions. You know, it's written in a way that it knows which browsers balk at certain types of code, and so if it's on that particular browser, it'll actually rewrite the code in runtime to make it work on that web browser. So that's a pretty interesting library. Used it for a while, and it kind of simplifies, if you ever use JavaScript, it kind of simplifies things a little bit as well. And then React is a JavaScript library, as you can see, developed by Facebook, and it's for creating modular user interfaces. And so this is basically when you want to create front ends, we call it in the web development world, so the ability for users to interact with the web page. You can do a lot of it with jQuery, but React is more when we're dealing with database. We need to go get information from the database. React helps quite a bit. In both cases, we can actually embed that code right into our HTML documents. In fact, React is pretty much all embedded in the HTML documents, whereas jQuery usually, well, jQuery is not usually, always, is a separate file itself that contains a lot of different libraries that you can use. So the frameworks, as I said, is what we've been dealing with regards to the Microsoft environment. If you're in the Java world, you use the Java SDK, Software Development Kit, and that basically has all the components that make up the Java framework. I've listed a few of the frameworks here for JavaScript. So Java and JavaScript are two completely different languages. Java is a language that requires the Java virtual machine in order for it to be able to process the code, whereas JavaScript, all you need to have is a web browser to process your code. So every modern day web browser has a JavaScript interpreter built into it. So that's nice as a developer because you don't have to worry about whether the client has a particular component installed to run your program or not. So in the JavaScript world, they've got Angular, that was developed by Google. TypeScript is becoming pretty big because one of the things about JavaScript is it's not a strongly typed language like C# where you have to identify your variable types as you're declaring them. So TypeScript basically takes that concept of being strictly data typed but applies it to the JavaScript language. So you do have to declare your variables with the data type in that TypeScript, but it actually makes for better coding. Because the problem, you know, JavaScript is so flexible, you know, it can be very easy to write code, but it's also very easy to make mistakes that can't be identified even at runtime in some cases. So just TypeScript makes it a little bit more reliable, the code that you're writing. And then WebAssembly is a really big deal these days. WebAssembly is already built into all of your web browsers. This is, I think Opera was the last holdout on that. I think Opera finally added it. WebAssembly will probably be one of the biggest technologies you start hearing about here within the next decade here, because the goal of WebAssembly is to take JavaScript code, optimize that code into a format that can be run in the web browser at the same speed that you would expect to get from a desktop-based application. So desktop-based applications, those are the ones that are already compiled, machine code compiled. So that means that the zeros and ones are what being loaded from the memory into the CPU, and so no translation has to occur there. So in WebAssembly, there still is a little bit of a translation that has to occur, and that's what kind of slows down the interpreted language, is the fact that it has to be interpreted on the fly, right? We have to convert the code to the zeros and the ones when it's running in the web browser. But the way that WebAssembly is set up is that it's actually your code will be optimized initially. Within the web browser, the code that gets sent down to the client has already been optimized for being what they call a web assembly. So you can see that it is in a binary instruction format, but it's just not compiled down to the actual machine code quite yet. So it takes, you know, like a millisecond longer for that processing to occur. In fact, the research that I've been doing on this, they say that they're essentially getting runtime comparisons now with the WebAssembly, meaning that the code, the program running in a web browser environment using WebAssembly, it runs just as fast as the code that's running on a desktop environment. And so because of the flexibility of the web and the fact that you don't have to install the program on your computer to have that functionality, you know, it just seems to me like WebAssembly might be the next big thing, and it might even make it so that we have a lot fewer desktop and even mobile applications, and that more often we'll just access different resources through a web browser that has WebAssembly programs being loaded into it. So just something to keep an eye on. Like I say, I think that's going to be very important coming years here. .NET framework we've been through before. Just want to reiterate what I was talking about earlier, the fact that the way that the .NET or the Visual Studio works is that we're using one of the supported languages, and it's using this Roslyn compiler to convert the code into this intermediary language. And so that was that executable file that I showed you in my folder here a moment ago. That was in this format, the MSIL. And then when I double clicked on the executable file, that was then passed over to the common language runtime that's running with the operating system, my Windows 10 operating system. And so that'll detect then which is the correct compiler to process my code. So it loads up what's called a just-in-time compiler, a JIT compiler. That's the correct compiler for my MSIL code on that particular system. So now it converts it into the final format, the machine code format that it needs to be in for the code to actually run on the CPU. And then it'll interact through the operating system to give us IO tasks and CPU bound tasks. So just remember, the OS has to have that CLR component installed in it. And the only real drawback here is that in this type of format, you always have to go through the OS. In other words, the OS is able to restrict what access we have to these two items down below, to the IO bound task and to the CPU bound tasks. Whereas in a C++ environment, you can actually write code that'll bypass the OS altogether and give you direct access to these items. Now that can actually be problematic too, because that can actually cause computers to crash. But, you know, and that's why really all the operating system companies have gone this route now, where the OS basically protects all of your hardware from the code that might have access to it. It dictates, it determines what code can have what access to these items. So C++ is one of the exceptions where you can still get direct access bypassing the OS. All right, so then we get to finding documentation. So I've just put some sections together here for you where you can find information on C# and the Microsoft .NET framework, and then JavaScript. You always want to use the Mozilla Developers Network. Those are the folks that invented JavaScript to begin with. C++, this is a pretty good site to get information about the C++ language, and then docs, python.org for the Python language. Now, the rest of this is just a series of videos by a pretty entertaining gentleman here, John Sonmez, and he goes through and talks about what it was like in his first programming job and how he got his first programming job and how to get a job without any experience, and do you need to have a degree? He has that whole discussion. So I'll leave those videos for you guys to watch on your own. I highly recommend that you watch them. If you're serious about being a programmer, this will give you some good insights to what it takes to become a programmer, to actually get your foot in the door and get yourself a job.